Hi friends, this is Syed Reshma Sharif. In this video lecture today I am going to discuss about continuous wave radar. In this video let us see what is continuous wave radar, how the block diagram is and what is the operations of continuous wave radar as well as its applications. Okay, let us see. Now what is the principle of continuous wave radar? Here the principle and operation, let us see. As opposed to pulsed radar system, a continuous wave radar system emits electromagnetic radiations all times. Here it continuously emits electromagnetic radiations. Okay, it continuously emits electromagnetic radiations. A conventional continuous wave radar cannot measure range because there is no basis for the measurement of the time delay. Okay, continuous wave radar cannot measure a range because there is no basis for measurement of time delay. Okay, time delay we don't know. So for this conventional continuous wave radar cannot measure its range. What is Doppler effect? How it is used in continuous wave radar? Actually, the time delay we do not find time delay, so that's why it cannot measure the range. So Doppler effect that is used in continuous wave radar for finding the range. Okay, let us see how this Doppler effect is used in continuous wave radar for finding its range. See here, this is a continuous electromagnetic radiations. Okay, here some delay is there, isn't it? After that it sends echo signals back to the radar. Okay, here this delay time is there now. This delay time can't be measured with this conventional continuous wave radar. So for this range, the measurement of time delay, how the Doppler effect is used in this radar. Let us see. Now what is Doppler effect? Doppler effect is nothing but a Doppler shift. Doppler effect or Doppler shift, both we can call. Okay, here is simply, it is nothing but a change in its frequency of wave. The change in its frequency of wave in relation to observer who is moving relative to the wave source. Who is moving relative to the wave source? The change in frequency of a wave, that is called as a Doppler effect. Doppler effect or Doppler shift is nothing but change in its frequency of wave in relation to an observer who is moving relative to the wave source. See, it detects the signal which is having Doppler frequency. Doppler amplifier, as name suggested, Doppler amplifier amplifies the signal which is having Doppler frequency. Okay, FD indicator, it is indicates the information related relatively velocity and whether the target is inbound or outbound. Okay, and here is the difference between continuous wave radar as well as pulsed radar. Here pulsed radar remains power for short periods of time, working with and without some form of modulation such as amplitude, frequency modulation or phase modulation. Okay, whereas continuous wave signals remains on constantly and may be modulated as functions as radars or in communication systems. This in pulsed signal, it without some form of modulations takes place in pulsed radar, whereas in continuous wave radar there is constant modulation takes place here. What are the limitations of continuous wave radar? The limitations means no timing marks, so unable to measure range. Because in previously only we discussed, isn't it? Because it does not have time delays, isn't it? So we cannot measure this. So we can't measure range. Separate antennas are required for both receiver and transmitter. It is also one kind of drawback or not? Cannot detect targets crossing its beam at right angles. If it crosses its beam at right angles, it cannot measure or detects a target. Okay, next, benefits of or advantages of continuous wave radar. It is used wide variety of applications, like it transmit power with low values and hence does not interfere other wireless devices. In previously we discussed that is continuous wave radar is used for low power transmission at military appliances, space stations, etc. Isn't it? What is continuous wave signal? A continuous wave signal or a continuous waveform is an electromagnetic wave of constant amplitude and frequency. A constant a continuous wave signal is nothing but a continuous waveform or an electromagnetic waves which are constant amplitude and constant frequency. Typically a sine wave. Okay, typically a sine wave. That is, a mathematical analysis is considered to be infinite duration. It to be infinite duration with same amplitude and same frequencies. Okay. The radar which operates with continuous signal waves or waves for detecting non-stationary targets is called as a continuous wave radar or simply continuous wave radar. Not all the targets are stationary. No, every target or some of the target they are movable in direction. In this case, this continuous wave radar is useful for detecting the non-stationary targets. It is called continuous wave radar or simply CW radar. This radar requires two antennas, among which one antenna is used for transmitting the signal and other antenna is used for receiving the signal. Here now the block diagram of radar. This is continuous wave radar. The block diagram of continuous wave Doppler radar contains a set of blocks. First one, CW transmitter, transmitting antenna, local oscillator, mixer 1, sideband filter, mixer 2, IF amplifier, detector, Doppler amplifier, indicator. Let us discuss about each block clearly. First of all, this continuous wave transmitter, the name itself, it produces an analog signal with having frequency f0 continuously. The output of continuous wave transmitter is connected to both transmitting antenna as well as mixer. This is connected to transmitting antenna as well as mixer. Okay, here it produces analog signals. This produces analog signals with frequency f0. It is connected to the output of transmitting antenna and is same as a mixer. Next one is local oscillator. It produces signals having frequency f1. In previously here f0 it produces f0 frequencies. Here local oscillator is produce f1 frequency. Then there is a time delay or not? F1 frequencies from local oscillator. The output of local oscillator is connected to mixer 1. Okay, this mixer 1 can produce both sum and difference of frequencies that are applied to it. From here we are having one kind of frequency f0. From here we are having another frequency f1. This mixer mixes both frequencies f0 and f1. Okay, f0 and f1. So the mixer m1 produces the output having frequencies f0 plus f1 or f0 minus f1. Differences produces here f0 plus f1 or f0 minus f1. Okay, f0 plus f1, f0 minus f1. Okay, sideband filter. The sideband filter is name suggested sideband allows a particular sideband frequencies, either upper sideband frequencies or lower sideband frequencies. Okay, either upper sideband frequencies or as lower sideband frequencies. The sideband filter as shown in above figure produces only upper sideband frequencies F0 plus F1. This shows only F0 plus F1, which shows the sideband filter. Here, the continuous wave radar transmit continuous signals with frequency F0 to the transmitting antenna as well as to the mixer. If with frequency F0 from local oscillators, again it sends frequency F1. Here, the mixer mixes both frequency, either the sum or difference between these two frequencies. If after that it sends to sideband filters, the sideband filters allows particular sideband frequencies, that is upper sideband frequencies or lower sideband frequencies. Here this sideband shows above figure shows that upper sideband frequencies, that is of F0 plus F1, F0 plus F1 frequencies. Okay. Here the mixer 2. After sidebands, mixer to mixer can produce both sum and difference of frequencies and apply to it. The signals having frequencies F0 plus F1 and F0 minus plus or minus Ft are applied to mixer 2. So the mixer 2 will produce the output having frequencies of F0 plus F1 plus Fd or F1 plus or minus Ft. Okay. Here the sum or difference between both frequencies here produced in this. IF amplifier. IF intermediate amplifier, it amplifies signals in intermediate frequency form. F1 plus F4 plus or minus Fd and amplifies it. Here detector detects signals which is having Doppler frequency Fd. Okay, it detects Doppler frequency, is having Doppler frequency or it detects. Next one, Doppler amplifier. It amplifiers. The name itself suggests that it amplifies the signal having Doppler frequency Fd. Okay, next one, indicator. This name indicator indicates the information related to relative velocity and whether the target is inbound or outbound. It means the target is within our boundary or not. This indicator indicates. This is entire block diagram of continuous wave Doppler frequency Doppler radar. Here this continuous wave transmitter transmits signals to the transmitter antenna and to the mixer with frequency F0. From local oscillator, again it has some frequencies F1. Here the mixer mixes both the sum of both frequencies from continuous wave radar and local oscillators. Okay, here that is mixer of F0 plus F1 or F0 minus F1. This sideband receives both side frequencies or any side frequency. Here it receives upper frequencies. Okay, upper frequency. After that, it from the mixer to it mixes some Doppler frequencies Fd plus or minus F0 plus Ft plus F1. Okay, here from IF amplifier it sends signal to IF amplifier. It signal here we get higher frequencies. This IF amplifier amplifies to intermediate frequency. From this it detects a signal. Is it a Doppler frequency present or not? It detects. After this detection, Doppler amplifier amplifies the Doppler frequency signals, and then the indicator indicates is does our target is in our boundary or not. It will find. This is about a continuous wave Doppler radar. These continuous wave radars are mostly radars which accurate measurements of relative velocities. Hence, these are used mostly where information of velocity is more important than the actual range. Okay, this is about a continuous If you have any doubts regarding this, please comment me on my comment section. Thank you for your watching.